Hello guys, so we are back again and today we are going to end the sequence series chapter as per Singage, okay? And we are going to do some miscellaneous solved examples of Singage, okay? And these question means there are total 15 question, okay? Even if you are able to do four or three question, it is fine, okay? Because the first time you see this type of question, they are very difficult, okay? First of all, okay? So please understand these problems and keep them in your mind, okay? So the first problem is as follow, okay, it says as follow: along a road lie an odd number of stones, okay, placed at intervals of 10 meter, okay. These stones have to be assembled around the middle stone, okay. A person can carry only one stone at a time, okay. A man does the job starting with one of the end stones by carrying all in successions, okay. In carrying all the stones he covered a distance of 3 kilometers. Find the total number of stones, okay. So we want to find the total number of stones, okay. What it is telling, that there is a road, okay. There is this kind of road, okay. We will assume this kind of, and this is the center, okay. There are, okay, we have to collect the stone at the middle, okay. So uh, okay, so there are odd number, okay. There are odd number of stones. So total number of stone will be what? Here there will be n stones and here there will be n stones, okay. Then there will be one middle stone, okay. Okay, in odd number there is only one middle term, okay. So total number of stone, okay, this is one stone, okay. This is the middle one, and here there are n stones and here there are n stones, okay. So total stones, and here the stones will be like this order: 1 3 odd number stones, 1 3 5 and so on, okay. And the distance which he travels to pick up the stone is 10 meter. He what succession means, okay. He is carrying all in succession, means he will take this stone, this is a point, this is b point, take this as b point, okay. Similar will happen here from this side, okay. So let me understand, okay. So here are, okay, here total n stones, okay. So 10 10 10 till n times will be this 10 to reach this point, okay. Further on, this stone will be n minus 1 from here, and this stone will be n minus 2 from here, okay. Similarly 10 10 distance stone will be placed. What he will do means, he will take one stone, he cannot take two stone at a time. He will take one stone, move this distance and back, come again and take this stone and place it here, and take this stone and place, and he will do this continuously, and doing this he covers 3 kilometer distance, okay. And we want to tell the number of stone which he will add, means he will have when he covers a distance of 3 kilometer, okay. Now we have got an idea that this is all, okay. This will be 10 meter, okay, and so on, okay. This is one total stone. First we should know total stones. Total stones are nothing but 2n, this n plus 1, okay. These are total number of stones, okay. Now let's understand the process, okay. He will take this stone, okay. He will start from a, okay. Start from a, then he will move here, okay. He will move till here, okay. And then he will travel what distance? First he will travel, okay, and okay, let's understand this, okay. Total distance, he will take this stone, okay, and 10 into n distance he will travel, okay. Again he will come and take this stone and again travel. So in this time he will travel n minus 1 and again n minus 1, okay, plus 2 into 10 into n minus 1, okay. Similarly now he will come again, he will travel n minus 2 distance, and then he will move again, sorry, he will first he will move here, then he will take n minus 1 distance and go here, 2 times n minus 1 distance. Similarly he will come here, n minus 2 distance, and move here, so 2 times n minus 2. Similarly will go on till n times. So what we are going to do, 2 into n minus 2. Similarly okay, 2 into 10 into n minus 3, okay, and so on will go on till what? Till this will continue, okay. This he will keep continuing doing it, okay, until what? 2 into 10 into 2, okay, and the last will be 10 into 1, okay. He will come here and then he will move here, only 10 meter distance, okay. So this is the first distance which it will travel. Okay. So one more thing, so hope you have understand the logic. The logic is very important. Okay, so distance, okay, this is what distance covered in collecting the stone. Okay, now let me tell you again what we happened. Okay, he was here, he moved here. Okay, he traveled 10 into n distance. He came here. Now he came here, he will not go till here, he will go till here. Why? Because he knows the second stone will be here. Okay, which is the odd stone. Okay, so this distance will be what, 10 into n minus 1, and then this will be next 10 means twice n minus 1, so twice n minus 1 and so on. Okay, and this will keep on happening till the last time, because the last will be here only. Okay, just here only one time. Okay, okay, now let's move on to the next thing. Okay, okay, let's do a little modification. 10 into n, take this to outside. Okay, then this is 10 into n minus 1. Okay, this is what 10 into n minus 2, and so on till what, till 10. Okay, so okay, this is okay, this is this. Okay, this is from here. Okay, this is not. Okay, I am writing it separately. Okay, the distance, okay, d1. Now just think again. Okay, now if he has collected all these stones from here, he will move here. Okay, then he will travel what, n distance, and then when he will pick these stones, think that this is the first stone from here. Okay, odd stone, he will reach here, so 10 into n distance, and then again he will move here to keep it in the middle. He has to travel twice and 10 into n. Here it was only once 10 into n. Okay, so the distance 2, okay, from the B point will be what, 2 into 10 into n, and then then again the process will be same. He will again come here, there is third stone, then he will come again n minus 1 distance and then move back. Okay, sorry, then he will come n minus 2, n minus 1 distance twice, so 10 plus 2 into 10 into n minus 1, and similarly 2 into 10 into n minus 2, and this will keep on happening. Okay, 2 into 10 into 2 and 10 into 1. Okay, so okay, so we will take the 2 common, 10 into n minus 1, 10 into n minus 2. Okay, and so on till 10. Okay, now what we can see, total distance. Okay, total distance will be what, adding the both d1 and d2, d1 plus d2 will give me what. Okay, now if we do one thing, okay, here there is 10 into n. Okay, 1 10 into n. Here there is 2 10 into n. This series will become this series if I add 1 10 into n and subtract 1 10 into n. Okay, let me make you understand what I'm telling. 10 into n plus 2 into 10 into n minus 1. Okay, 10 into n minus 2, and so on till 10, and again here 2 into 10 into n plus 10 into n minus 1, and so on till 10. Okay, now I will do what, I will add here 10 into n and subtract here 10 into n. What it will do, it will make it 2 10 into n, then this whole thing will add on and become 4 times. Okay, then what will be 4 into 10 into n plus 10 into n minus 1. Okay, and this so on till 10 into n. Okay, okay, and this 10 into n will be left here. Now we will take 10 common, 40 into n minus 1. Okay, and so on till what, 1. Okay, so here there are n terms. Okay, so what is the sum of n terms? Okay, what is the sum of n terms? It is nothing but 40 into n plus 1 by 2 minus 10 into n. Okay, now what will be the next step? 20 will cancel out, giving me 20 n square plus 20 n minus 10 n. This will become 20 n square minus 10 n plus 10 n. Okay, so here you have seen that we got the total distance. Okay, Now to get what okay, one more thing. Okay, there are he will travel n times, okay, n times 10 distance, which indirectly gives you a hint that at n distance each stone is placed, okay, whether it is odd. So n gives us the number of stones, okay. I think this thing I have forgot to tell, okay, but it also gives you idea that 10 will come n times, okay. Now one more thing, what they have told, that total distance which he traveled was nothing but 3 kilometer. So distance traveled given, okay, which is nothing but 3 kilometer, which is 3 into 1000, which is 3000. Okay, sorry, I have to do it. Okay, now we can do one thing. Okay, we will just solve this. 20n square plus 10n is equals to 3000. Okay, 2n square plus n is equals to 300. Okay, now to solve this, okay, we will bring it here. 2n square, okay, 2n square plus n minus 300 should be equal to 0. What how we can break 300? Okay, 3 into this should be 600. Okay, and then breaking. Okay, we can break it like this: n minus 12 and 2n plus 25, okay, equal to 0. Let me take the next page. Okay, we will do it here only. Okay, so n is equals to minus 25 by 2 is not possible because stones cannot be negative. So n is equals to 12 is the only possible answer left. Okay, so but we have already told the total number of stones which we will have will be nothing but, okay, 2 into, okay, at every n position, okay, stones are placed, so total stone will be nothing but 2n plus 1. Okay, so we will place this 12 here. The total stones, okay, total stones will be nothing but 2 into 12 plus 1, which will give me 24 plus 1, which will be 25. Okay, so hope you have understand this problem. Let me revise the problem again. The problem was like this: a person, okay, in a road, odd number stones are placed, okay, so total stone, and there is a single stone at the middle. What does it mean? That there are total stones, then there is only one middle stone, which gives you a hint that the total number of stones on the road should be 2n plus 1. Okay, here should be n, here should be n, then only in in odd number, then only there is only one middle term. Okay, in odd number only there is one middle term. Okay, the next question is as follows. This is the next question. Okay, this question is means a bit of means about advanced level. Okay, I will say that let p, okay, is greater than 0 be the first of the n arithmetic team. Okay, and means between two numbers, and the first of n arithmetic, q be the first n arithmetic means between the same numbers. Okay, then prove that q does not belongs to p comma n plus 1 upon n minus 1 the whole square p, and q does not, okay, p does not belongs to n minus 1 upon n plus 1 the whole square q into q. Okay, so we want to prove this. Okay, first let's do this. First, between whose, let the two number b, a and b, most common thing, a and b. What they are telling, between two number a and b, the first means, if I insert n arithmetic means, the first arithmetic mean is what, p, and similarly n arithmetic means between 1 upon a and 1 upon b, if they are in harmonic mean, then the first h1 is nothing but q. Okay, a, p and q are greater than 0, that's all, and we have to prove this, that p does not belong to this and q does not belong to this. Okay, now the next step which we can do, okay, which is means very obvious, that a comma p comma, okay, a2 and so on till an. Okay, and this will be b. D will be very obvious, b minus a upon n plus 1. Okay, after doing this step we got the d. Okay, the p will be what? P will be a plus b minus a upon n plus 1, which give me what? n a plus b minus a upon n plus 1, which will lead to what? n a plus b upon n plus 1. Okay, so we got the p thing. P is what? n a plus b upon n plus 1. Similarly, two numbers between, so 1 by a, okay, 1 by a, 1 upon q, 1 upon h2 and so on, 1 upon hn upon 1 upon b are in ap if they are in harmonic mean. Okay, So we can find that dd is what, 1 by b minus 1 by a upon n plus 1, giving me what, a minus b upon ab into n plus 1. So we got this thing. Okay, after this thing, 1 by q is what, 1 by q is nothing but 1 by a plus a minus b upon ab n plus 1. After this, ab n plus ab, okay, sorry, here we are doing a mistake. What that, take 1 by a common. Okay, then our problem will be solved. A n plus b plus a minus b upon a b n plus 1. Okay, after this, okay, after this what we can do, okay, let me do it here. After this, it is very clear that the answer will be nothing but b n plus a upon a b n plus 1. So we got the q value also. Okay, we got the q value also. And let me take the next page. Okay, so the p value is nothing but n a plus b upon n plus 1. 1 upon q value, sorry, 1 upon q. This is q value, this is 1 upon q value. 1 upon q value is what, b n plus a upon a b n plus 1. So 1 upon q value will be what, q value will be what, a b n plus 1 upon b n plus a. Okay, so we got the two things. Okay, now can we get the b value from here? Okay, b value will be p into n plus 1 minus n a is equals to b. We will get this and substitute it here. Okay, okay, so let me take it as 1. Okay, so from 1 we'll put it here. Okay, from 1, okay, from 1 we will put this value here. First, q b n plus q a, okay, will be what, a, okay, a b n plus 1. First let's means modify this. Okay, after this what we can do, okay, after this what we can do, this a n p q, okay, we should do like this. Okay, a n, okay, a n will be there. Okay, a n, sorry, q n into b value will be what, p into n plus 1 minus a n. Okay, after this plus q a, okay, should be equal to what, n plus 1. Okay, n plus 1, a will be there only, p into n plus 1 minus a n. Okay, okay, so this thing we got. Okay, after this, right, the next step will be what, aq plus n pq into n plus 1 minus aq n square. Okay, we multiplied this, we get after this what we are getting, after this we are getting it like this. Okay, after this we have opened this. Okay, all the things. Okay, nothing is left, right? Let me check, nothing is left. Okay, okay, now what we can do, n a p, okay, into n plus 1, okay, into n plus 1 minus a square n square plus ap n plus 1 minus a square n. Okay, okay, now what we can do after this, okay, what we did, okay, we did nothing but, okay, we just multiplied the things, okay, and got one thing. Okay, after this what we are going to do, okay, we multiplied this with this and this with this. Okay, all the things. Okay, then we got this equation. After this what we can do, we can do one thing, 1 minus n square into aq plus npq into n plus 1. Okay, the calculation is quite bit difficult. Okay, I can, okay, it is difficult to n plus 1. Okay, and minus a square n into n plus 1. Okay, after this what we can do, okay, if I divide throughout by n plus 1, okay, divide throughout by n plus 1, what we get, 1 minus n aq plus npq is equals to ap n plus 1 minus a square n. Okay, we had an idea of making quadratic in 8 terms. Okay, that's why we did this. Okay, from start. Okay, I hope I have forgot to tell that. Okay, first you have to select one term in which you want to make quadratic, because here it was very clear it is going to form a quadratic. okay, plus npq is equals to 0. Okay, so I brought these terms, okay, and made a quadratic, and take this was minus, so taking outside will become like this. Okay, so after this, with this is the quadratic. Okay, now this is the very common step which we do in quadratic for since, okay, since a is real. Okay, for real d is greater than 0, so d is greater than equal to 0. Okay, we will apply this condition, which is as follow: n plus 1 p plus n minus 1 q the whole square minus 4n square pq should be what, greater than equal to 0. Okay, after this what we can do, n minus 1 the whole square q square plus 2 into n square minus 1 into pq plus n plus 1 into n plus 1 the whole square p square minus 4 n square p into q should be greater than equal to 0. Okay, after this what we can do, n minus 1 the whole square q square plus 2 into n square minus 1 minus 4n, okay, minus 4n square, because these both are same, into pq, okay, plus n plus 1 the whole square into p square is greater than equal to 0. After this what we can do, n minus 1 the whole square into q square plus, okay, I can take, okay, this will be what, nothing but minus 2n square minus 2 pq, okay, and plus n plus 1 the whole square like this, p square greater than equal to 0. After this n minus 1 the whole square q square minus 2 we can take common, okay, n square plus 1 into pq, okay, this is the thing which left, n plus 1 the whole square into p square greater than equal to 0. After this we will divide it by n plus 1 the whole square, giving me into 2 into n square plus 1 upon n minus 1 the whole square, okay, pq plus n plus 1 upon n minus 1 the whole square into p square is greater than equal to 0. Okay, after this step we will do one quite means a manipulation. You should know that this manipulation is very common. Okay, this manipulation means this is very understandable manipulation. Okay, if you open n plus 1 the whole square plus n minus 1 the whole square, what you get? Okay, you get nothing but 2n square plus 2. Okay, so we can write it like this whole term. So we will write it like this, minus 2 into n plus 1 the whole square, okay, plus n minus 1 the whole square upon n minus 1 the whole square into pq. Okay, after doing this, n plus 1 n minus 1 the whole square p square greater than equal to 0. Okay, now it is very obvious what will be the next step, q square, okay, minus pq minus n plus 1 upon n minus 1 the whole square into pq plus n plus 1 upon n minus 1 the whole square p square is greater than equal to 0. Okay, so this was very general, okay, the general approach. Okay, now after this what we will do, okay, after this what we will do one thing, okay, taking q common, q minus p. Okay, after here we will take this n plus 1 the whole square upon n minus 1 common, okay, n plus 1 upon n minus 1 the whole square common into p, okay, which will give me nothing but, okay, which will give me what, q minus p. So here we are getting the same thing, greater than equal to 0. So we will do what, we will move forward, okay, this by using quadratic, okay, this minus n plus 1 the upon n minus 1 the whole square, okay, into p. Okay, we can write it like this, and q minus p is greater than equal to 0 using quadratic thing. Okay, after that it is very simple. Okay, you can understand it. Okay, after means this thing is very simple. Okay, now to analyze, you can think it like x minus a into x minus b. If it is reason, what we do, we just write the number name, whatever is greater, like here n plus 1 is greater, n plus 1 upon n minus 1 is greater than, p is greater than n, this is p, then it is very simple that positive, negative, positive. Okay, so the answer should be from here, this section is right and this section is right, then answer cannot be between these two. Okay, so it is very obvious that q cannot belong to what, n plus 1 upon n minus 1 the whole square, p and comma p. Okay, so we came to know this. Okay, inside from here these numbers are included because it is greater than equal to, these numbers are included. Okay, but inside they are not included. Okay, inside terms should not belong from inside. Okay, it means that. Okay, similarly we can do this next thing. Okay, it is very general. You can do this means multiply this here, means just do this n minus 1 upon, okay, and divided by this n plus 1 the whole square q minus p. Okay, and the base means the base will become same. Okay, the base will become same and it will move that side. Okay, means nothing great. Okay, it is very simple. Okay, just you need to break, means you have to break it similarly, means here you have to do a little manipulation. Okay, you have to break it with different way. Okay guys, so q does not belongs to n plus 1 upon n minus 1 the whole square p into comma p. Okay, similarly you can prove this also. Okay, similarly you can prove that p does not belongs to what, n plus 1 upon n minus 1 q comma q. Okay, similarly you can prove this also. Okay, now proving this again is just sheer nonsense. Okay, you can do this. Okay, so from this we can clearly see that. Okay, but you can see how calculation was hectic. This calculation is very tough. Okay, this means attempting this question in exam is just like wasting your time. Okay, although you know, go for such questions in the end. Okay, but it is a theoretical proof. Okay, so we have proved that q does not belongs to this and p does not belongs to this. That was all we wanted to prove. Okay, hope you have understand all the things. Okay, let me prove that all the again. First, the two numbers. Okay, we have taken a and b, between them there were n APs. We found the d, we found the first term p, because p is all I need, because they all in my general which I have to prove p is there. I found the p value. In the next 1 upon a and 1 upon b and h1 h2 h3, this will be the series, but I will reverse them 1 upon, then I will get a in ap. Okay, then I found the d, I took them 1 upon, because why, my 1 upon h1 is nothing but 1 upon q. Okay, if they were 1 upon a comma h1 h2, then it would be an hp. Okay, but 1 upon a, then it will be in ap. Okay, then I find the d, I reverse the d, I got the q value, I substituted the b value from 1. Okay, then a quadratic, I made a quadratic. Okay, now listen, doing all this calculation I did it on the basis of deciding that I have to make a quadratic in terms of a. Okay, if you don't decide that, then you are doing wrong. Okay, after deciding this, then I made this and then I applied a is real. Okay, after that we solved this. Okay, because the number, you know that when we take a and between two, the number are real. Okay, applied these properties. Okay, and then found this. All these basic information no teachers tells you, because they think that you have already understood them. Okay, now let's move on to the next question. This question was quite big. Okay, that's why I was telling that these are miscellaneous problems and they are not, means they're not that much easy. Okay, so the next question is as follow. This is the next question, which says if Sn is equals to 1 plus 1 upon 2 plus 1 upon 3 till so on till 1 upon n. Okay, n belongs to natural number, then prove that S1 plus S2 plus and so on Sn minus 1 is equals to n Sn minus n, or n Sn minus 1 minus n plus 1. Okay, now one thing which is very clear, that we want to S1 S2 S3. It's means if I do this, S1 is this. Okay, then plus S2 and so on. If I write this till Sn minus 1, okay, observe this. Okay, this will be 1. Okay, and from, if I add them vertical, like writing S2 here 1 plus, because you have to observe, such things come by observation. Okay, you can solve this question by observation. Okay, if you observe, you will, and then the third S3. Okay, when they ask you such things, sums, okay, like n minus 1 till Sn sum, then do this 1 plus 1 by 2 plus 1 by 3. Okay, and so on, and it will go till the end. Okay, and what will be the last, 1 plus 1 by 2 plus 1 by 3 and so on till what, 1 upon what, here it, what they have given, n. Okay, and it will go on till what we have, this is still Sn minus 1, so we will have n minus 1. Okay, but they have given it. Okay, we are taking this series. Okay, not this. Okay, it will go on till Sn minus 1. Okay, so you got an idea. Now if I add them vertically, here we have Sn minus 1 terms, so these are also Sn minus 1. So this is what, this is nothing but n minus 1 terms, and this is starting from, if this is n minus 1, this is starting from second. What it is n minus 2 upon 2, and similarly this is what, n minus 3 upon 3, and so on. And what will be the last? Just think, this is the last will be 1 upon n minus 1. Okay, it is very easy. The last one is very easy to predict. Okay, now what will be my next task? My next task will be nothing but just, okay, here you can clearly see, if I open this, n minus 1 plus n by 2, this will be 1, this will be n by 3, and this will be 1, and so on till what, the last will be n minus 1. Okay, you can easily understand this. After this 1 minus 1 I will take outside, and I will be left with n by 2, n by 3, and so on till what, I will be left with 1 upon n minus 1. And here I will take all the ones, 1 1 1. How many time 1 will be there? Just think, if I take the 1 continuously, how many 1 will be there? 1 1, and here all the ones I have added. Okay, and here if I take n common, 1 plus 1 by 2 and 1 by 3, and so on till 1 upon, okay, 1 upon n 1 minus 1. Okay, now just think that here how many terms will be. From n we got one term. Okay, it is starting from n. Okay, it is starting from n and ending to 1. Okay, so how many 1 will be there? It will be n. Okay, that is the trick part. Okay, listen, these are n minus 1. Okay, from here we came to click that it is n minus 1. This will be n minus 2 because it is starting from 2, it is starting from t, and so on. It will decrease and go on to 1. Now when you divide this will be 1 minus 1, this will be n by 2 minus 1. Okay, 2 will divide by 2 become 1, and all things will open. Similarly, in the end you will take all these terms and take the negative terms, but here you notice one thing, that it is starting from n and ending to 1, means it has n terms. So from all of this 1 will come n times, so here n will be there. Okay, but you remember one thing, that this is nothing but, this is what, if you remember one thing, this is what, okay, sorry, I have done a mistake. This will be, okay, I think I did a mistake. This will be n minus 1. Let me check, and it is still n minus 1. So if I add all the ones, it will be n minus, okay, it will be n minus 1. Okay, my mistake, I have, okay, sorry, I have taken n. Okay, it is n minus 1 one term, n minus, it is starting from n minus 1. I have taken n like that. Okay, shit, my observation was wrong. Okay, it is starting from n minus 1 and so on till 1. So 1 is taken n minus 1 times, so it will be n minus 1. Okay, sorry for my bad. Okay, I have taken like this, n from n is like this, and it is decreasing to 1. Okay, I thought that, but it's starting from n minus 1. I observed that only. Okay, sorry, my mistake. From here you can see n minus 1. Okay, so it is reaching to 1. So there are, when it will break up in one term, it will be n minus 1 times 1. Okay, and we know that what it is Sn minus 1. Okay, let me continue here. Okay, it is what, Sn minus 1 into n. This is what, Sn minus 1. Okay, and it is n minus 1, which when I open n into Sn minus 1 minus n plus 1. So we have proved what we wanted to prove. Okay, and nothing else is means nothing great we see in this problem. Okay, just you get an idea that you should add vertically when S1 S2 S2 like 3 questions asked. Okay, so when this type of question are asked, you should think vertically, that if you would add vertically, you can get this. Okay, although this proof also gives a hint that we should think like that. Okay, so this was the proof of this question. We added them vertically. We got an idea that when I means it will be n minus 1, this will be n minus 2, and so on, and the last term will be 1 upon n minus 1, and then when I divide them, it broke up into 1 n minus 1, n by 2 minus 1, n by 3, and these terms will form Sn minus 1, and these will be n minus 1 one times. 1 will be n repeated till n minus 1 times. So this, from this we gave this. Okay, so this is question number 6. Now let's move on to the next question. The next question is this. This is question number 7, which says find the sum of 1 into 2 minus omega into 2 minus omega square plus 2 into 3 minus omega into 3 minus omega square, and so on. Okay, and so on till n minus 1 into n minus omega into n minus omega square, where omega is the imaginary cube root of unity. Okay, so hope you know the basic properties of cube root of unity. Okay, it is means you should know that. Okay, the sum is already given s. Okay, there is no need to write that. We need to find the tn, although you can easily see the tn. They have given the tn. Okay, the tn is given n minus 1 into n minus omega into n minus omega square. Okay, if I multiply this, what I get? N minus 1 into n square minus n omega square plus n omega square. Okay, n square minus, okay, plus omega cube minus omega n. Okay, after this, if you can see omega square is nothing but 1, n square minus n omega square plus omega. Okay, n plus 1. Okay, omega square is 1, omega cube is 1. Okay, this is the property of cube root of roots of unity. Okay, imaginary cube root of unity. And one more property, omega square plus omega plus 1 is equals to 0. So what I will do, add plus 1 and subtract minus 1. Okay, so n minus 1 into n square minus n into omega square plus omega plus 1 minus 1 plus 1. Here you can clearly see what we are getting, n minus 1 into n square minus n. Okay, this is what, minus 1 plus 1, this whole thing will become 0 and this minus 1 will be left, n minus 1 into n square plus n plus 1. And now you can recognize this formula, this is nothing but n cube minus 1 formula. Okay, now how we find the Sn? Find Sn. So Sn is nothing but summation Tn. So when I do the summation of n cube minus 1, okay, which is means not a tough thing. Okay, you can do it, which is from what, n is equals to 1 to n is equals to 2, because at n is equals to, okay, fine, well, let me think where it is from. Okay, it is starting from 1. Okay, from n is equals to 1 to n. Okay, now we will apply this. N cube is nothing but n into n plus 1 by 2 the whole square minus n. Okay, after this you can solve, okay, and get the answer. Okay, there is nothing great after solving this. Okay, let me solve this. N square into n plus 1 the whole square minus 4n the whole upon 2. Okay, so this is all. Okay, 4, this will be 4. Okay, so this is all with this problem. This problem was nothing but just you should know these two properties, which you will learn in more detail in complex number. Now let's move on to the next problem. This is problem number 8. Okay, which tells find the value of triple summation. Okay, summation I is equals to 0 to infinity, j is equals to 0 to infinity, summation k is equals to 0 to infinity. Okay, now I want to tell you one thing, that this question is not from sigma dependent. Okay, you can clearly see that this is a question from sigma independent. Okay, we in such question appear sigma dependent, sigma independent. Okay, independent, you have to means this type of question will tell you to solve sigma in more ease. Okay, you mostly till now you have learned the first basic way of solving sigma, that is separating them and solving them. This question will teach you the second way of solving sigma in cases. Okay, how? Let me tell you. Case 1, in this you have to take the cases of I, j and k. Okay, the case 1 is nothing but that I is not equal to j is not equal to k. Okay, this is nothing that they are not meaning here by that this is not equal. They are telling that any student can assume one wrong thing, that I is equals to j, so he will put 1 sigma and here he will do 3 cube. Okay, to avoid that mistake, he is telling that they are not equal. Okay, although they start from same thing, any student can take the same value. Okay, so to avoid that mistake, they are taking this. Okay, now here this we are considering a case. Okay, this is something else which they are telling the student. Okay, this is case which you are taking, that I, j and k are different. Okay, if this is true, then I can do one basic thing. I can then separate them as per sigma 1 upon 3i summation j is equals to 0 to infinity 1 upon 3j, and summation k is equals to 0 to infinity 1 upon 3k. Okay, so I have separated them as per sigma. Now what I can do, 1 upon 3 0 1 plus 1 by 3, I will solve 1 and it will be same for the rest too, plus 1 upon 3 square and so on till infinity. If I calculate the sum of infinity is nothing but 1 upon 3, which will give me 3 by 2. So I got the sum. So if I want to get this sum, I will call it S1. This will be what, 1 by 3 by 2. Okay, 3 by 2 into 3 by 2 into 3 by 2, the cube, which is nothing but 27 by 8. So we got S1. Now we will take the case 2. Case 2 is nothing but I is equals to j not equal to k. Okay, I is equals to j not equal to k. Okay, and there are three possibilities of this case, which is I is equals to k but not equal to j. I is equals to j is done. J is equals to k not equal to I. Okay, three possibilities, but we are taking this first. Okay, so the sum three times will be the sum. Okay, because three possibilities are there for this. Okay, if I try to find out, you can clearly see that these two will become equal. Okay, so I can write them. I is equals to 0 from infinity 1 upon 3 square, which is nothing but 9i. Okay, this is very simple. 9i into summation, k is different, so k is equals to 0 to infinity 1 upon 3i. We know this value. Okay, we know this value. This is nothing but I is equals to 0 to infinity. I can write it 1 upon 2i, and this is nothing but 3 by 2. Okay, now one thing I want to tell. If you open this series, just think this. Okay, if I take it 3 square. Okay, if you even take 9, the first will be 1, the second will be what, 9, the third will be what, 9 okay, 9 square 81, and so on. Now listen, at some point, okay, at some point when you solve this, okay, these three, because it is a multiple of 9. Okay, so if you open 1 plus 1 by 3 plus 1 by 9, 1 by 27, so you can see the terms are coming same. So but these two and these, so you can see that some terms are coming same, and we have already told that I is equal to j but not equal to k. If k terms are same in ij, okay, then we mean this condition will not be satisfied. To make this condition valid, we have to subtract the things, means 3 by I. Okay, the total sum minus 3 by I. Okay, because some terms can be possible which are in this are present in this. Okay, for that we will do what, minus 3 by I. Okay, after doing this you can clearly see, okay, let me take the next page. What you can see, that summation I is equals to 0 to infinity 3 by 2 come outside, 1 upon 3 2i. Okay, minus summation I is equals to 0 to infinity 1 upon, okay, 1 upon 3 power 3i. Okay, now what you can see, 3 by 2. Okay, so after this step what we will do, this will be nothing but, if I open it, 1 plus 9 81 and so on till infinity, and this will be nothing but 1 plus 1 upon 27 and so on till infinity. Okay, so you can clearly see this is 3 by 2 into, okay, 1 upon 1 minus 1 by 9, and this is nothing but 1 upon 1 minus 1 by 27. Okay, which gives you what, 3 by 2 into 9 by 8 minus 27 by 26, which leads to 135 by 208. Okay, so this is the required. Okay, now let's take the case 3. Case 3 is what, when I is equals to j is equals to k, what this sigma will become 1. I will take I will make I same in them, then it will be nothing but 3 cube I, which is nothing but 1 plus 1 upon 27 and so on till infinity, which is nothing but 1 upon 1 by 27, which will give me 27 upon 26. So the s, which is the sum of the total which is possible, which will be s1, this is s2, this is s3. Okay, this is s3. Three cases are possible. S1, okay, plus okay, plus s2. S2 is what, 3 times s2. Okay, 3 times s2. Okay, okay, sorry, the first case is what, when all are same. Okay, when all are different. Okay, let me think. When all are equal, okay, okay, we cannot directly add them. Okay, there is a process. Okay, so we will add it like this, the s1, okay, in which all the cases are different, minus this case s2, in which 2 becomes equal and 1 becomes different. Okay, which is this case s2. Okay, this case s2, which gives us nothing but, okay, So S1, which is all in which all the cases are different, and the second is this case, okay, which is 27 by 6, okay, which is S3 minus 3 times. I told you this three conditions are possible in this 208. Okay, it's okay. Okay, here they are independent, means max sum, which is this. Okay, in this, when there are two are equal, okay, all are equal, and when two are equal, okay, after doing this, what you get, okay, let me do it in the next page. Okay, the thing which you get is 27 into 26, this, if we take LCM, into 28 minus 3 into 135, right, upon 208, which gives you nothing but 81 upon 208. Okay, so this is our answer. Okay, let me teach you what happened. In such question we take the cases. The first case was if all are unequal. Okay, in this, if they are unequal, we will move the int in sigmas which are as per their means this subscript. So we moved it, and then we find the value of 1 sigma, and it will be similar for this, and we got this. Okay, after this, if we take the second case, okay, in this we did 2 are equal, okay, which is a subset of these cases. Okay, so if you notice, okay, we got here 3 possibilities are there for this case. Okay, okay, and this will be the max sum possible. Okay, and okay, and the last will be when 3 are equal, okay, which will be the least sum. Okay, so after subtracting from the max sum, we got the finally the sum possible. Okay, okay, so this was the question number 8. Okay, it gives you an idea how to deal with 3 summations. Just get this max one, okay, and subtract the else, okay, which are the possible in general. Okay, and the rest are this. You can also compare the values, which one is, this is very low, this is low, and this is the biggest compared to them. Okay, the most sum in which you would solve them independently. Okay, now let's move on to the next question. Okay, I will use this page, okay, in the next question. Okay, now the next question is as follow. Okay, the next question is as follow. Let me take the next question. The next question, where is the next question? Okay, the next question is here. Okay, this is the next question. Okay, find the sum. Okay, this is the next question. Find the sum. Summation j is equals to 1 to 10, summation I is equals to 1 to 10, I into 2 to power j. Okay, so how we will solve this? Here you can again solve this by cases. Okay, case 1 is what, when I is equals to j. Okay, okay, here 2 cases will be only possible. Okay, so this case, okay, when they are equal, you can directly deal them like this. Okay, if you open them, you can deal them in I is equals to 1 to 10, I into 2 to power I, which if I open 1 into 2 plus 2 into 2 power 2 plus 3 into 2 power 3, and so on till what, 10 into 2 to power 10. Okay, if I called it S, then in the next step, S is this 1 into 2 in plus 2 into 2 power 2 plus 3 into 2 power 3, and the last is 10 into 2 power 10. And the next step we will multiply with the common ratio, which is 2. 2s is nothing but 1 into 2 power 2, 2 into, this is the sum of difference method. Okay, sum and when the difference is constant method, 3 into 2 power 4, and so on. What will the last, 10 into 2 power, okay, 9 into 2 power 10, and the last will be 10 into 2 power 11. Okay, if I subtract them, what I get, minus s is equals to 1 into 2 plus 2 power 2 plus 2 power 3, and so on till what, 2 power 10 minus, this will be minus 10 into 2 power 11. After this, you can clearly see its sum will be what, its sum will be nothing of 1 to 10, 2 power 10 minus 1 upon 2 into upon what, 2 into, this will be 2 minus 1. Okay, 2 minus 1, which is nothing, 10 into 2 power 11. After this, if I open this, 2 power 11 minus 2 minus 10 into 2 power 11, which I subtract, get minus 9 into 2 power 11 minus 2, and this is minus s. If I multiply it with minus sign, what I get, s is equals to what, 2 plus 9 into 2 power 11. Okay, so this is our S. Okay, case 1. Now let's move for case 2. Case 2 is what? Case 2 is what? When I is not equal to j, they will move in different summations. I is equals to 1 to 10, I cap will be this, and 2 power j will be this. Summation j is equals to 1 to 10, which will give me this. This is S2. Okay, take it as S2, take it as S1, doesn't matter. Okay, 2 power 1, 2 power 2, and so on till 2 power 10. Okay, this is 1 and this is 1 plus 2 plus 3 still 10, and the common ratio is 2 into 2 power 10 minus 1 upon 2 minus 1. After this is nothing but n into n plus 1, 11 upon 2, which gives me this is nothing but 2 into 2 to power 10 minus 2 into okay, this will be nothing but 1 2, okay, 1 1 1 0. Okay, this will be nothing but 1 1 0. Okay, so we got this. After this, what we can do? Okay, this what we can do? Okay, after this, okay, this will be 2. Here the 2 will cancel, giving me 2 power 10 minus 1 into, okay, 1 1 0. Okay, after this is our S2. Okay, we know the process of solving it further. The means the possible case, this is the max. We have told you that this is the max, this will give you max answer. So S will be nothing but S2 minus S1, okay, which is nothing but 2 power 10 minus 1 into 10 1 1 10 minus 2 plus 9 into 2 power 11. Okay, after this, okay, this is just a bad calculation question. Okay, we will leave it here only. Okay, so this is our answer. Hope you have understand. Okay, just learn this, that this case will give you max answer and the rest case you have to subtract it. Okay, in this type of question, double, triple, no matter how many, just you have, the cases will increase. Okay, so now let's move on to the next question. The next question is as follows. This is the next question. Okay, which says find the coefficient of x power 18 in 1 plus x plus 2 into x square, 3 into x cube, and so on till 18 into x power 18 the whole square. Okay, now if I write this, okay, for the coefficient if I write this like this, x into 2x square, so on till 18 x power 18 into 1 plus x plus 2x square, and so on till 18 x power 18. Okay, so you can see when x power 18 will appear, when this will multiply with this, 1 will multiply with 18. Okay, this will multiply with this, x cube x power 18 will appear, 2 will multiply with 2 power what, 2 power, this will multiply with, okay, this will multiply with 18, this 1 will multiply with 17 x power 17. Okay, we are taking the terms only. Okay, x power 18 will be same in all of them. In the third, this will be formed when 2 is multiplied with 16. Okay, and so on, and the last will be what, 1 18 is multiplied by 1. Okay, x power 18 it is this. Okay, so here you can see these, the last term before this will be what, 17 into 2. Okay, so here you can see they are in what, in AP following some pattern. Okay, while these they are different. Okay, so we will add them separately. Although you can see one more thing. Okay, if you try to add them, the one starting one are equal, so they will not be in AP. Okay, so we will add them. 36, these two we have taken, the rest is 1 into 17 plus 2 into 16, and so until 17 into 2. Okay, so we have to add them. Okay, for them we have to consider the general term to get the summation. Okay, to get the summation, r is equals to 1 to, okay, 1, this will be 1, and this will be what, okay, this will be what. Okay, so this, how we can write for it, the first term should be 17. Okay, 18 minus r. Okay, and this, if you want, okay, this should be 17. Okay, 18. Okay, the first, okay, and the last will be fine, we are going right. Okay, this will go on 1 2 3. Okay, so we are getting 1, and here we are getting 17. Okay, so we got this. Okay, after this what we can do, this will open. Okay, we will multiply it. Okay, and take the 18 outside. Okay, then we will solve it. Okay, now let's solve this. Okay, this will, if I open, r is equals to 1 to 17, 36 will remain as it is. 18 r minus r square. Okay, after this 36 plus summation r is equals to 1 to 17. 18 will come outside, r into r plus 1 upon 2 minus r into r plus 1 into 2r plus 1 upon 6 upon 6. Okay, will be what? 36 plus add sorry, this will move out. We will put these values. 18 here, 17 into 18 upon 2, and here the values will be put 17 into 18 into, okay, 34 plus 1 upon 6. Okay, so this will be what? 18 into 34 plus 1 5. 36 into this will be what become 9 into 17 into 18, and this will be what? 17 into 9. Okay, this will be 6, and this downward will be 2. 35 by 2. Okay, which will lead me to what? 1005. Okay, so this is our answer. Hope you have understand breaking it and the ideology of it to multiplying with 18. Why? Because all now don't, this will be x power 18, all the terms coefficient will be x power 18. Okay, that was the ideology. Okay, and this type of question you will learn more to solve this more effectively in binomial theorem. Okay, they continuously ask, find the middle term, find this term, find this term. Okay, some exact terms also. Okay, they will give you some expansions. Okay, expand this and find this term. Okay, in that will be more complex and it will make you more comfortable in this type of question. So wait for the binomial theorem and we will solve this type of question. Then you will be able to solve this question directly. Okay, you don't need to use sequence series. Okay, so we are done with this question. Now let's move on to the next question. Okay, the next question is this. Okay, which is this: let a1 comma a2 till a and b real numbers such that under root a1 plus under root a2 minus 1 plus under root a3 minus 2 and so on under root an minus n minus 1 is equals to 1 upon 2 a1 plus a2 and so on till an minus n into n minus 3 upon 4. Okay, then find the value of this. Okay, summation I is equals to 1 to 100 ai. Okay, now if I do this, okay, if I consider this thing, this, and instead of n, if I take I minus 1 as bi, if I consider this, then what I get? This is general Tn term. Okay, so what you can clearly see, bi square plus I minus 1, I will get ai value. Okay, and one more thing. Okay, if I apply summation, okay, if I apply summation I is equals to 1 to n, okay, this will be equal to this. Okay, this will be equal to this summation bi square plus I minus 1, I is equals to 1 to n. Okay, this will be, if you remember, this is nothing but this. Okay, this is nothing but this. So hope you have understand what we meant by using this. Okay, and this is nothing but bi. Okay, if I use summation, this is general Tn, if I apply summation I is equals to 1 to n and apply a summation I is equals to 1 to n, they are equal. Okay, we have assumed this, then I can replace it, I is equals to 1 to n bi, and then this thing which is equal to this. Okay, we can put this summation I is equals to 1 to n bi square plus I into I plus 1 by 2, when I apply summation here minus I. Okay, so this thing will be happen. Okay, and one more thing, I by 2 will be there here. Okay, I by 2 is outside this. Okay, 1 by 2, sorry, and here will be nothing but n minus 3 upon 4. Okay, we will add here n. Okay, because we have applied summation n plus 1 and here will be n. Okay, after applying this, now let's solve this. Okay, this will be n square plus n minus 2n upon 2. Okay, and here 1 by 2 will be there, like that only. I is equals to 1 to n bi square. Okay, this will be nothing but minus n into n minus 3 upon 4. Okay, after this what we can do, 1 by 2 summation bi will be like that only. Okay, summation I is equals to 1 to n bi square. This will cancel out, giving me n into n minus 1 upon, okay, I have multiplied here 1 by 2 and here it will be 1 by 4 minus n into n minus 3 upon 4. Now their both denominators are equal, So we will continue solving them. Rest thing will be same as it is. This will be summation bi only, bi square, okay, bi square, okay, and this will be what? This will be n square minus n, and this will be minus n square plus 3n upon 4, okay, which gives you this 2 will cancel out, giving me here 2n upon 2. Okay, I am solving it further. This will give me n square will cancel out, giving me 2n upon 4 will give me n by 2. Okay, so what we are left with, summation I is equals to 1 to n, bi is equals to 1 by 2 summation I is equals to 1 to n bi square, okay, and this is what, n by 2, okay, and this is what, n by 2. So we got this. Okay, after this we will multiply it by 2, which will give me, and then we will move it this side, okay, and if I apply summation here, it will be what? So this will become like this. Okay, after this step you will understand more quickly. Multiply by 2, what will be left? I is equals to 1 to n. Okay, I am applying summation to all of them. 2 will cancel out and giving me bi square. Listen, when I apply summation and multiply by 2, this 2 will cancel out. If I multiply by 2, one thing, n will be left. Okay, if I remove this, 1 will be left, because as if I apply summation, 1 becomes n, and if I remove summation, it will become 1 before only, but the thing will be, it will be in summation 1. Now we will move this, the summation is same from 1 to n, then it will become, okay, it will become what? It will become summation, all the summations are same, bi square minus 2bi, because I can clearly see they are forming a square plus a square minus b square, a minus b the whole square, which gives me summation I is equals to 1 to n bi minus 1 the whole square. Okay, so I got this. And when a square is equal, when that individual term becomes 0, by1 becomes 0, it is only equal to 0 when it becomes 0, because x square is greater than equal to 0, then bi is equal to 0. Greater than is not possible, so equal to 0 is only the possible case. So bi is equals to 0. If bi is equals to 0, okay, then bi, okay, bi is equals to 1. If bi minus 1 is equals to 0, bi is equals to 1, sorry. Okay, so we got this thing. Okay, when we get this thing, we know that bi is what? If bi is 1, okay, we have considered this thing. Remember, ai minus I minus 1 is equals to bi. If I put here 1, okay, then what I get? I put I is equals to 1, bi, we want b1, okay, b1 will be what? b1 will also be equal to 1. Okay, so what we are getting? ai, this is 1 square, okay, bi minus 1, this will become 0, ai will be nothing but 1. Okay, so came to know that a1 is also equal to 1. Okay, ai is also equal, sorry, ai is equals to 1. Okay, okay, so after this what we can do? After this we can do one thing, that we want summation I is equals to 1 to 100 ai, then we will add, it is 1, then it will be nothing but added 100 times. Okay, sorry, it is ai, so it will be 1 at first. Okay, it will open simply 1 plus 2 plus and so on till 100, and then we will get it sum as 100 into 101 upon 2. Okay, okay, so hope you have understand what I meant. Okay, the problem till here you have understood. Okay, bi we put here 1 square will become 1 only. Then listen, ai, okay, under root ai, okay, minus I minus 1, we will move here, it is 1. Then here when I move it, 1 plus I minus 1 will become I. So ai is equals to 1, ai is equals to I. So we can ai is equals to I. When I put ai is equals to I, it will open 1 for 1, 2 for 2, and so on till 100. 100 into 101 upon 2. Okay, I think we have told 1. Okay, sorry, my mistake. It is 1. Here it will be I. Okay, okay, so we came to know this answer. Okay, the main important thing is that under root, when you put ai minus I minus 1, here it is 1, and this will become 1 minus I plus I minus 1, which will give me ai is equals to I. When I put it in summation, I is equals to 1 200, I think I told 1. Okay, sorry, 1 plus 2, and then it will open, because at I is equals to 1, it is 1 2 10 so on till 100, and we know the summation of 100 n into n plus 1. 101 upon 2. Okay, it is used most frequently formula. Okay, so now we have solved this question. Okay, hope you have understood all the steps. Okay, assuming this is the critical part. Okay, if you understand that step, although you should keep remember these questions. Okay, and solve it multiple times, so when it appears you don't leave it. Okay, so let's move on to the next question. The next question is as follow. This is the next question, question number 12, which says a sequence of number an comma n is equals to 1 2 3 and so on is defined as follows. A1 is equals to 1 by 2 and n for n greater than equal to 2, an is equals to 2n minus 3 upon 2 and an minus 1 into an minus 1. Then prove that summation r is equals to 1 to n ar is less than 1. Okay, so here we have been given a1 is equals to 1. Okay, 1 by 2, fine. An is what? 2n minus 3 upon 2n into an minus 1, and it is for n greater than equal to 2. Okay, if I replace ar, then 2r minus 1 upon 2r ar minus 1, r will be also greater than equal to 2. Okay, ar into 2r will be equal to 2r ar minus 1 minus ar minus 1. Okay, so here, okay, this is 3. Okay, so here we can see a telescopic series is forming. Okay, if you can see, then it is, you will, although you will come to know after this step, minus 2, if I break it like this, then a telescopic series will be formed. This is based on your observation. Okay, these proofs are based on your observation. Okay, now if I move it here, 2r ar minus 1 plus 2 ar minus 1 is equals to minus ar minus 1. Okay, okay, now to this, if we do this ar minus ar, we will take common, this will be ar minus 1. Okay, ar minus 1, this will become plus. Okay, no, keep it minus only. Okay, if I keep it minus, this will become 2 taken common, r plus 1. Okay, r plus 1 into ar minus 1. Okay, so it is r, then it is r plus 1. Okay, okay, wait, let me think what mistake we are doing. This will become positive, this will become negative. Fine, is there any mistake which we are doing? Okay, so for your understanding we will solve it like this, otherwise you will not understand what I am telling. ar is given, we will take 2 common here, what we, and ar minus 1 will be left, ar minus 1. Okay, we will move it here, and here minus ar minus 1 is left. 2ar minus 2 into ar minus 1 into ar minus 1. Okay, because I want to create this and it will become difficult for you to understand if I do it at that time, at that position. Okay, now you can clearly see r is r minus 1, difference is 1, here difference is 1, and if I apply summation, r is equals to what? It will become from 2. Okay, although it is very obvious that it will become from 2, and it should have n terms. So if it starts from 2, what position it will stop to have n terms? R plus 1. Okay, n plus 1, we take n plus 1, and here similarly will happen, we will apply the same summation, r is equal to n plus 1. Okay, and then we will substitute the value, giving me, this is the bigger one, 2 into n plus 1 into a n plus 1 minus 2 into, if I substitute, this will become 1 into a 2, means what? A only will be left, and here if I open this, okay, let me open this, if it is equal to, if I open this, it will be nothing but a1 minus will be there only, a1 and a2 and so on till an. So we can write it like this, it has n term, r is equals to 1 to n minus ar. Okay, because it is giving this thing only. Okay, it has n terms. So after this step we can do one basic manipulation, which will, it is negative, we will move it that side, which will give me positive ar, r is equals to 1 to n, and we will move this to this side, ar1 minus 2 into n plus 1 into a n plus 1, which here a1 value we know that 2 into 1 by 2 minus 2 into n plus 1 into a n plus 1, this is 1 minus 2 n plus 1 upon an plus 1. Okay, so here summation r is equals to 1 to n ar. So you can clearly see that it will always be negative because an plus 1 is positive. Okay, it is always positive. Okay, you can see, so this will be always negative. Okay, because r is greater than equal to 1, r is equals to 1 to n. Okay, so what this gives you, it gives you that we have proved that ar, which is this, is always less than 1 because it will be negative because this is always positive. Okay, so we have proved this. The most important thing was deriving it from here, n plus 1. Why it will be n plus 1? Because it should also have n terms. Okay, that is also important thing. Okay, then you should see one more thing, that it should form a telescopic series. If you don't realize, then it is very difficult to prove this thing. Okay, after analyzing, you have to solve it. Try to make the things in the left side only like this, otherwise you cannot make the arrangement here, it will become wrong. And one more thing, that you have to rearrange the summation because you have to prove from r is equals to 1 to n. Okay, so we have done this problem. Hope you have understand the problem because this is a very good problem. Okay, now let's move on to the next problem. The next problem is this. Okay, if f of f r is r, okay, r to r, okay, r satisfied for r, okay, is a continuous such that f of x minus f of x by 2 is equals to 4x square by 3 for x belonging to f of 0 is equals to 0, then find the other. Okay, you can solve this by differentiability, okay, and continuity, using continuity and differentiability. Okay, its domain is all r natural number. Okay, r to r. Okay, you will learn about into function, onto function, and so on in function chapter. But here, if we try to solve it by sequence series, you can clearly see that it is f of x minus f of x by 2 and it is 4x square by 3. If I replace x by what, replace x by 2, what I get, f of x by 2 minus f of x by 4, and this will become what, 4x square by 4 by 3. Okay, similarly replace x by 4, what I get, f of x by 4 minus f of x by 8 is equals to 4 by 3 x square upon, it will be 4 square will be what, 16. Okay, and so on. Now and so on till n. Okay, now in the end, if I add them all, you can clearly see that these two will cancel out, and so on, all the things will cancel out, and the last thing will be what, f of x power 2 power n minus 1 minus f of x power 2 power n. Okay, and this will also cancel out. Okay, so what you can see, okay, and it is for infinity. Okay, this n is tending to infinity. For solving this, we have to take n is equals to infinity. Okay, what we are left with, f of x minus f of x by 2 power n, and here 4 by 3 x square we will take common, what are left with 1 upon 4 and 1 upon 16, and so on till infinity. Since we have taken, it will tends to 0. Okay, and then what we are left with, f of x is equals to 4 by 3 x square. Okay, if I take the sum of this, it will be nothing but 1 upon 1 by 4 by 3. Okay, 1 by 4, which will give you 4 by 3 x square into what, 4, this will become 4 by 3, giving you what. Okay, so we are left with 16 x square by 9. Okay, now what we want, we want f of 3 by 2. Okay, let me solve it here. If I put x is equals to 3 by 2, what I get, f of what, f of 9 by 4. Okay, 16 by 9 is nothing but here will be what, 9 by 4, which will give me 4 only. Okay, so this is our answer, f of 3 by 2. Okay, just you need to analyze that it will be a pattern. If I replace x by 2 and then add them, I will get this. If to solve this, and should tend to infinity. Okay, that is the thing. Or also f of 0 is equals to 0. Okay, after this, and it will be 0 only if this tends to 0. F of x will be 0 only if this tends to 0. Okay, which they are trying to give you hint by this. And after this, you can get the answer by putting x is equals to 3 by 2. Okay, so we are done with this problem. Now let's move on to the next problem. Okay, let me get the next problem. I think. Okay, so the next problem is this one. Okay, this is the next problem. Find the value of summation r is equals to 1 to n 1 upon r and summation k is equals to 1 to n. Okay, if I take summation r is equals to 1 to 1 upon r as what? If I take this as b, okay, if we open this, what we get? If we open this, which is b 1 to n, what we are getting? Okay, 1 upon 1, 1 upon 2, 1 upon 3, and so on till 1 upon n. Similarly, we will consider the second part, which is summation k is equals to 1 to n k upon 2n minus 2k plus 1 into 2n minus k plus 1 as what? A. Okay, now here we have to break it. Now how we will analyze? First thing, the process is f r plus 1 minus f of r. Okay, now how we will analyze? Just put the value, put here k is equals to 1, what get? 2 minus 2 plus 1, and here what I get? 2n only. So this one is surely 2n minus 1, which is smaller, and this one is bigger. So f of r plus 2 minus f of r plus 1 minus f of r is nothing but what we can do. Okay, we will do this 2n minus k plus 1, okay, minus 2n minus 2k plus 1. Okay, and after this 2n minus 2k plus 1 into 2n minus k plus 1. One more thing, now let's check this 2n minus whether it gives us k or not. Okay, if not, then we have to do manipulations. 2k plus 1. Okay, then okay, this will become minus. Okay, then okay, we are getting k, so we don't need to multiply and divide by some number. Okay, so what is our next step? Our next step will be, let me take the next page. Our next step will be nothing but, okay, we have to open it, which will give me this summation k is equals to 1. Okay, I will divide the summation 2 in this same step. Okay, otherwise it will just be a wastage of a step. Okay, 2n minus 2k plus 1. Okay, minus summation k is equals to 1 to n 1 upon 2n minus k plus 1. Okay, after this what we can do? Okay, after this what we can do? We will do one thing, we will just open this. Okay, open this. We will first open this one. Okay, this k is equals to 1 to n 1 upon 2n minus 2k plus 1. Okay, when we open it, put 1, 2n minus 2 plus 1, 1 upon 2n minus 4 plus 1, 1 upon 2n minus 6 plus 1, and so on. Now let's put 1 upon 2n minus n minus 1 plus 1, 1 upon 2n minus 2n plus 1. Okay, now if I analyze this 2n minus 1 plus 1 upon 2n minus 3 plus 1 upon 2n minus 5 and so on, what is the final term? This will cancel out. Okay, and this will become plus 1. Okay, so n plus 1, n plus 2, and this will be what? 1 upon, this will cancel out, giving me 1. Okay, wait a second, this is 2 now, here is 2, so 2n, 2 to n will cancel out, 2 plus 1. Okay, this will be nothing but 3. Okay, so here something surprising happened, that it started from backwards. Okay, it should start from here, so we will just rewrite it 1 upon 1, 1 upon 3. So next time you can click that it will be 5, and so on. What will be the last term? 1 upon 2 5 minus 2n minus 5. Okay, plus 1 upon 2n minus 3 and plus 1 upon 2n minus 1. Okay, so this is our sum. Okay, we will consider it as a. Okay, so we got one thing, which is this one. Okay, now let's identify the second one, which is summation k is equals to 1 to n 1 upon 2n minus k plus 1. Okay, if I open it, 1 upon 2n minus 1 plus 1, 1 upon 2n minus 2 plus 1, 1 upon 2n minus 3 plus 1, and so on. Now let's move on to 1 upon 2n minus n minus 1 plus 1, 1 upon 2n minus n plus 1. Okay, what we get? 1 upon 2n, 1 upon 2n minus 1, 1 upon 2n minus 2, and so on. What is the last term? N plus 2 here n plus 1. Okay, so we got this thing. Now we will subtract them. Okay, now we will subtract them. Okay, so our a is nothing but this thing, 1 upon 1 plus 1 upon 3 plus 1 upon 5 till 1 upon 2n minus 1. Okay, and negative of this we will write in reverse. 1 upon this one is also opposite. You can see this. Now this, listen, it is starting from 2n and then decreasing and it is reaching to n plus 1. So we should start from here, because if you can see, this is surprising thing, because this series is unique. It is giving us reverse sum. Okay, it should start from here, but it is starting from here. Sometimes it happens in some problems, so that's why these are miscellaneous problems. Okay, so 1 upon n plus 1, n plus 2, 1 upon n plus 3. Okay, and so on till what? 1 upon 2n minus 1, and lastly 1 upon 2n. Okay, so what we can do? Okay, now in the b, okay, we have a, okay, we have b. In the b there are n terms, and here we have till 2n terms. Okay, if I add them, okay, we will have a complete set of 2n terms, and this will be, this we can calculate separately. Okay, so what we should do? Okay, to add them, okay, we should do b minus a. So after doing b minus a will give us what? 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 and so on till 1 upon n. Okay, will be added with 1 upon n plus 1, because this is negative 1 upon n plus 2. Okay, it was ending at 1 upon n. This is starting from n plus 1, n plus 3 and so on. What we got? Till 1 upon 2n. Now what will be subtracted? Minus all the odd terms, 1 upon 3, 1 upon 5, 1 upon 7 and so on till 1 upon 2n minus 1. Okay, all the terms subtracted. Now here you can clearly see that it has all the terms, but it has only the even terms from till 1 to 2n. Okay, so it will remove all the odd terms from this 2n. Okay, which will give us the final series like this. Okay, which will be, means it will have only even terms, 1 upon 2, 1 upon 4, 1 upon 6. Okay, these problems are tough, I know, but there is no way, you have to do it. Okay, means this question you have to do again and again, because these questions are not easy. Now if I take 1 by 2 common, okay, this means this is the trap part. Here if you are not able to click 1 upon 2, then the entire thing is just waste. Okay, okay, and so on till 1 upon n. Now you can observe this is nothing but b. Okay, if you observe, this is nothing but b, so this will be 1 upon 2 into b upon b minus a. Okay, and here b minus 1 upon 2b will be a by this relation, which will give me b by 2 is nothing but a, which will give me b by a is nothing but 2. Okay, but what is the use of this? Okay, if you observe, this is b. Okay, so this problem is nothing but, this is b and this is what? This is a. So this problem is nothing but b by a value, and we got that b by a value is nothing but equal to 2. So in these problems, in such type of problem, you have to, means, take them separately, assume them, solve them separately. Okay, okay, I know these problems are difficult, but you have to solve this problem at least 5 times. Okay, these problems you have to solve at least 5 times. Okay, then only you can solve similar problems like this. Okay, now let's move on to the next problem. The next problem is as follow. Okay, okay, the next problem is as follow. Okay, this is the next problem. Find the sum of from n is equals to 1 to infinity 6n upon 3n minus 2n into 3n plus 1 minus 2n plus 1. Okay, the first step is very similar. Okay, means that is a step first, tr is already given. Okay, step 2 is breaking it fr plus 1. Okay, like that. So how we can do? First, I know that fr plus 1 will be this there is no doubt, minus 3n minus 2n. Okay, it is very clear that this will not give me n, 6n. But if I do one thing, that here if I add, okay, let me think, if I add 3n, okay, and here if I add 3 power, okay, 3n plus 1, okay, let me calculate 3n plus 2 minus 3, this will cancel out. Okay, okay, yes, it is giving 6n. Okay, now 3 power n minus 2 power n into 3 power n plus 1. Okay, you can calculate it, this is basic exponential thing. Okay, 2 power n plus 1. Okay, so after doing this, okay, we can break it. Summation is still here, n is equals to 1 to infinity. We applied what? F of r plus 1 minus f of r. Okay, so the one more thing here, this will break into 3 upon n upon 3 upon n minus 2 power n minus 3 power n plus 1 upon 3 power n plus 1 minus 2 power n plus 1. To make it more simplified, divide throughout by denominator and numerator by 3n, and here by 3n plus 1 upon 1 minus 2 by 3 power n, and here 1 upon 1 minus 2 by 3 power n plus 1. Okay, so we got this thing. After here you can clearly observe that this is what? This is n, this is n plus 1. So what we have to do? Substitute the values straightforwardly. Vn minus Vn plus 1. So very easy. 1 upon 1 minus 2 by 3 minus 1 upon 1 by 2 by 3 power n plus 1. Okay, but n tends to infinity. Okay, so 2 by 3 n plus 1 will tend to 0. Okay, but only this thing will tend to 0. 1 will still remain. This 1 will nothing happen to it. Okay, so what we got? 3 upon 3 minus 2, and here 1. After this we are getting 3 minus 1, which is nothing but 2. Okay, so this is our answer. Okay, the main important thing is breaking it up. Okay, the rest thing is very simple, anyone can do it. Okay, now one thing, in many problems you will face this problem that like r minus 2 upon r plus 3, r plus 4, these type of problems are given. How to break this, how to apply f of r plus 1. Okay, like that stuff. Okay, in that you should use this partial fraction thing. This thing will be used in integration. Okay, integration means continuously. Okay, in the last. Okay, so this thing works when its power, this power, okay, the numerator power is less than the denominator power. Okay, okay, but listen, if I have something like r minus 2, okay, upon r plus 3, like take this problem only, r plus 4. Okay, I want to break it into like this, a upon r plus 3. First take this one here and take the next one here, r plus 4. Okay, now here also there are two varieties, completely partial fraction and incomplete. Okay, that thing is means a little more advanced. Okay, in the solving means when I am solving problems I will tell you that also. Okay, you don't need to worry. Okay, but in this problem just see. Okay, this is integration part. Okay, but I am teaching you because it might be. Okay, now multiply this whole thing throughout. So this will cancel out, giving me r plus 4. The process is same for even if it is quadratic. Okay, here it is quadratic, then also the process will be same. Okay, this process of partial fraction is very great. Okay, it's always problem easy. Now try to make both of them 0. Put r is equals to 4 minus 4, then this one will become 0. Okay, and to make this, put r is equals to minus 3 0. First, when we put r is equals to minus 4, what will happen? This will become minus 6, this will become 0, b will become what? Minus 1. Okay, which will give me b is nothing but 6. Okay, when we put r is equals to minus 3, what will happen? Minus 5 will happen here. Here a will stay there. Okay, so and this will become b into 0, which will be 0. So a is equals to minus 5 is our answer. So we can straightforwardly this thing, r plus 3, r plus 4 will broke up into this simple 6 upon r plus 4. Sorry, I written it here, upon minus 5 upon r plus 3. Now when does this thing becomes wrong? Okay, let me tell you that. Now see this case, r minus 3, r minus 2, r minus 4, r plus 4, r minus 5. Okay, take this. How to solve this one? Assume a upon r minus 2, b upon r plus 4. Okay, take the terms like this, c upon r minus 5. Okay, then multiply throughout this whole thing. You will get again a into r plus 4 into r minus 5. This process is still same, doesn't matter. I told you r minus 2, r minus 5, and c into r minus 2, r plus 4. Okay, now do the same thing. Put r is equals to minus 4. You will get this one 0, this one 0. B you will get answer minus 7 is equals to this one become minus 6, minus 6 minus 9, minus 6 minus 9. Okay, which will give you B answer. Put r is equals to 2, which will be this one 0, this one 0, give you this answer, which will be minus 1 is equals to put r is equals to 2, give me a into 6 into minus 3, which gives you, okay, which gives you a value. Okay, which will be 18. Okay, 1 by 18 is equals to a, and this will be nothing but 7 by 54. Okay, minus 7 by 54 will be b. Now put r is equals to 5. Okay, if you put 5, this one will become 0, this one will become 0, you will get this answer. This will be 2 is equals to 5 will be c into 3 into 9. Okay, which will give you 2 by 27 will give you c. Okay, now you will say that I have broken this into this thing, r minus 2. Listen, this is where the partial fraction fails in VN method. Okay, although nobody tells, but see, 1 by 18 r minus 2, when they do integration, okay, if the student practices telescope series, then he realized that this thing fails here again. Okay, so here will be what, plus 2 by 27 and into r minus 5. So you now telescopic series will apply on two things. Then what this will happen, okay, you have to solve it separately. Okay, there is no other way. Guess if it is simplifiable, you will see some problems where it happens. Okay, these two you will be able to solve, but this one you won't be solved. Okay, so that's why many teachers prefer that using FR. Okay, that's why I tell you prefer FR plus 1 if it is solvable by that. Okay, a little manipulation you can use that. Okay, you're that much smart. Okay, you can use that f of r plus 1, because going to partial fraction you can see how much stuff it is. Okay, if you practice continuously, your speed will means increase, not a doubt. Okay, but okay, here if you got 3 terms, you have to take 2 terms. Guess what, if it is Vn and this is Vn plus 2, then you have to add Vn plus 1, and here also Vn plus 1. Okay, then these two form, this will still remain outside. Okay, so if now if you tell what happened if this doesn't simplify, then that will be other case, and that they will have shortly given some condition to solve that. Okay, but this is the main means problem. Okay, the time period increases of solving the problem. Second thing, when some problems, children don't try to think that they don't try to increase their smartness by thinking like f of r plus 1. Okay, mostly problems you have seen which I have solved includes the f of r plus 1 minus f of r. Okay, right, because many problems you have to just multiply a little bit and that's that much stuff, but you going to this, okay, practicing this will be helpful to you in integration. Okay, so we are done with this miscellaneous. Okay, we are going to start with solved example, and in the end we are going to do logarithmic and exponential, and then we will move to inequalities, I guess. Okay, although logarithmic and exponential can be in the end after the inequality, because inequalities are quite important. Okay, so till then, take care, see you in the next lecture. Okay, we are done with our sequence series, Singage, progression and series part. Okay, from Singage all the solve example. Okay, all the solve example plus application. Okay, plus application. It is about 200 plus question, 200 plus questions. Okay, which is very, now we will do some more 300 like that question, and then plus other institution question, which will boost and make you a very smart guy in sequence and series, so that in future when you go for engineering, you don't get scared by seeing sequence and series, this section. Okay, making problem to you. Okay, till then, take care.